Hello everyone, welcome once more to another video in our YouTube channel. So in this video we look at the West Regional Mock Physics Paper 2 of 2024. We are going to be solving a question from electrostatics, specifically on capacitors. The question reads: a capacitor of capacitance 8 microfarad in a vacuum is powered by a 12.0 volt DC supply. After charging the capacitor, a dielectric with permittivity epsilon equal to 6 epsilon 0, where epsilon 0 is the permittivity of vacuum, is inserted between the plates of the capacitor. A. Calculate the charge stored by the capacitor while in the vacuum. B. Explain the effect of the dielectric on the capacitance of the capacitor. And C. Determine the energy stored by the capacitor after inserting the dielectric. So for the first question, we need to calculate the charge stored by the capacitor while in vacuum, meaning while the dielectric was not yet inserted. So the charge is just equal to the capacitance times the voltage, and the capacitance initially is 8 microfarads and the DC supply had a voltage of 12 volts. It therefore means that my charge stored will be 8 microfarads times 12 volts. Farads multiplied by volts just gives you the coulomb. So we are at the end of the day we have 8 times 12, which gives you 96.0 microcoulombs. But micro means 10 to the negative 6. So we have the charge stored initially is 96 times 10 to the negative 6 coulombs. Now in the second part of the equation, we need to explain the effect of the dielectric on the capacitance of the capacitor. So the capacitance of a capacitor can be expressed in terms of the permittivity of the medium. So generally the capacitance is the permittivity of a medium times the area on the plate separation. So epsilon is the permittivity of the medium involved, D is the plate separation, and A is their area. So initially, if it is vacuum, then the medium, if the medium is vacuum, then the permittivity of vacuum is epsilon 0, and with that the capacitance will be epsilon 0 A divided by D. Now at the instant where you insert a dielectric, the medium is now basically that of the dielectric, so the capacitance will be epsilon A divided by D, where this epsilon here is the permittivity of that dielectric. So in this case we have that epsilon is equal to 6 epsilon 0. It therefore means that my capacitance will be 6 epsilon 0 A divided by D, which means that we can write it as 6 times epsilon 0 A over D, knowing fully well that epsilon 0 A over D is the original capacitance when the medium was vacuum. So we have that the new capacitance is 6 times the original capacitance. So in conclusion, the capacitance of the capacitor will increase, and specifically increase by a factor of 6. Now the last question, we need to determine the energy stored by the capacitor after inserting the dielectric. So that energy generally is the capacitance times the DC supplied voltage squared divided by 2, half CV squared. But the C involved here is the capacitance of the capacitor when the dielectric was inserted, and it is C1. Now we know that C1 is equal to 6 times C. It therefore means that our energy stored will be 6C times the V squared divided by 2. Now what is the capacitance of the capacitor? The capacitance of the capacitor is actually 8.0 microfarads, while the voltage of the DC power supply is 12.0 volts. So we just have to replace into this formula and we get the answer. Tell me your answer in the comment section. Thank you guys for watching, and see you in the next video. Don't forget to like, share and subscribe to the channel.